Good morning, everyone. In this video, we are going to talk about the classification metrics. All right. In the classification problems, there are many evaluation metrics you can use to evaluate a machine learning model. These videos will cover some basic fundamentals metrics. All right. So let's start with the confusion matrix. What is a confusion matrix? Confusion matrix has four components: false positive, false negative, true positive, and true negative. To make things simpler, we will start with binary classification problems. Of course, this concept can be extended to multi-class classification. All right, let's start with binary classification. So assume that we are training a machine learning model. For this training, we have a data set of 100 patients, where half of them are COVID patients and half of them are non-COVID patients. So what we are going to do is, by providing some data about the patients, we want our machine learning model to be able to predict whether this patient has COVID or not. Okay, so we have trained the model, and now we are going to evaluate this model. This model predict two things: predict whether a patient has a COVID or not, based on the data that we provided. All right, based on the patient's data that we provided to the model. So now we are going to evaluate this model whether they perform as we expected using our training data. Okay, let's see how it goes. All right. So our model provide predict provide an answer, right? Either as a positive or negative. Left side is a positive, right side is negative. Okay, so let's start with the positive cases. So for the cases that we predict, our model predict as positive, can lead to two things. One is, yes, the patient has COVID, and our model also predict as positive. Since our model is predict as positive, it is positive case, and because this positive is the correct cases, true cases, all right, it is called true positive on the leftmost side. Okay. In another cases of positive, yes, our model predict as positive, but actual fact is that the patient doesn't have any COVID. So in this case, we predict as positive, but our positive is wrong, so it is called false positive. On the other hand, the model predict as negative. So in the negative case, like positive cases, all right, in this prediction, it can also have the correct positive or wrong, correct negative or wrong negative, all right. So if the patient doesn't have a COVID, so the patient doesn't have the COVID, and our model predict as negative, so it is correct one. So it is called true negative. Our model predict as negative, but the patient has COVID, so it is called false negative. So these are the four components, basic four components of the confusion metric. So when you draw a confusion metric can be drawn as a 2 by 2 matrix. All right. So if you look at on the particle, it is a predicted value. We predict as positive. Yes, actually it is also positive. So first row, first column. All right, shown with the blue, positive, positive. So it is called true positive. If you look at on the first column, we predict everything as positive. All right. So this positive, first row is true positive, but second row is a false positive. Likewise for false negative and true negative. Obviously, what is our main objective? We want to get the blue color as highest, right? We want to get both true positive and true negative, and we want to reduce the false positive and false negative. But not all our model will be able to achieve 100% as we expected. Okay, so we have to understand what do we mean by positive cases and negative cases. So let's look at on our COVID cases. All right, our positive means the patient has a COVID. Negative means the patient doesn't have a COVID. So what does a false positive mean? False positive means that a patient doesn't have a COVID, but the doctor tells this patient that yes, you have the COVID. Okay, so he might end up doing the quarantine even though he doesn't have a COVID. So that is the consequence of telling a false positive, having a lot of false positive in our model. Patients, inconvenience. All right, patients, depressions. Okay, so we want to reduce as much as possible. On the other hand, what is a negative? Negative is non-COVID. All right. So what do we mean by false negative? Okay, our model tell that okay, this patient doesn't have a COVID, but actually he or she is having a COVID. So he might end up going around the region and then he might spread the virus, or he might suffer without having a proper medical treatment. All right. So these are the consequences. So these consequences can be severe if the patient doesn't have the proper medical treatment in time. So we have to reduce their false negative. So you have to balance, right? Of course, both are important, but which one is much more important and which one is more tricky? So false positive is sometimes called it as a false alarm. You will hear a lot of false alarm, like fire false alarm, right? You hear the smoker detecting as a fire alarm. So these are the false alarm. We want to reduce the false alarm. But at the same time, we don't want to have the wrong prediction. All right, we don't want to miss out any of the cases, patient cases. So we want to reduce the false negative. So for us to be able to identify these false positive, false negative, there are another evaluation metrics based on these parameter, right? These parameter of the confusion matrix, we come out with different other evaluation metrics, which are like precision, recall, accuracy, and F1 score. So let's see what is precision. Oh, okay, sorry. Let's start with accuracy. All right, what is accuracy? It is the easiest one to understand. Accuracy means all the correct prediction. All correct prediction means both true positive and true negative. And you will sum them all, and then you will divide by the total number of input samples. All right. So this gives the accuracy of the model. So true positive plus true negative by total sample. This is the accuracy. But most of the cases, accuracy alone is not sufficient. So we will look at on other evaluation metrics such as precision. What is a precision? Precision is the ratio of the positive cases that model predicted are true positive. So out of the models that out of the positive cases the model predicted, all right, how many are accurately correct? So this is the precision. How precise our model is. Next, look at on the recall. All right. So what is a recall? Recall is calculated as the true positive divided by true positive plus false negative. What does it mean? How do we interpret? Okay. So false negative mean they are actually positive, but we predicted wrong. Right? So this is a false negative. So this is look at from the your data sample side. So out of 100 patients side, we have half of them are COVID. All right, 50 COVID cases. But our model is cannot detect all of them. Our model is detecting out of 50, maybe we 40 as a positive, 10 as a negative. So out of 50, only 40 are able to detect. So this measurement is called recall. All right. So both precisions and recall, if you look at it, recall is if you have the higher recall, that means you have the lowest false negative. If you look at on the precision, if you have the higher precision, you have the lower false positive. So increasing the precision is reducing the false positive. Increasing the recall is reducing the false negative. So both precisions and recalls are important evaluation metrics. But sometimes you may have to balance it. All right. Higher precision sometimes can lead to a lower recall. Higher recall can lead to a lower precision. We have to see how it goes. So sometimes we use F1 score, which measure both of them. All right. So basically, F1 score is a harmonic mean of the precision and recall values and calculated by 2 times precision times recall divided by precision plus recalls. So these are the four basic evaluation metrics that we can use based on the confusion matrix result. All right, developed from the confusion matrix. Confusion matrix, yeah. So in this video, we start with confusion matrix followed by these evaluation score that we have to use to evaluate the performance of our model. Now let's look at an example. If you are looking at the scikit-learn library in Python, this is a classification matrix report that you can generate. In this classification report, you can see that there are four columns: precision, recall, F1 score, and support. We have already know what is precision, what is recall, and F1 score. What is a support? So in this scikit-learn library, support means the number of sample. All right, number of sample. So if you look at the support column, the first row is telling us there are 12,796. This 12,796 belong to negative classes. How do we know? If you look at on the first row, left column, there is a zero. That means a negative cases. Second row is a positive cases. So there are 290 positive cases and 12,796 negative cases. Obviously, this data set is a imbalanced data set, more negative than positive. So if you understand this support, we already able to read this classification report. Okay, what does one mean? The first row is telling for the negative cases. All right. So precision for negative cases is 1. Precision recall for negative is also 1. So F1 score is also 1. So all are 1 for the negative cases. Then if you look at on the positive cases, which is a second row, there is a 0.96 precision, 98 precision, 0.82 recall, and 0.9 F1 score. This is how you have to read this classification report. And third row provide you the accuracy value. All right. So if you recall how we calculate the accuracy doesn't have for positive or negative. Accuracy is all the correct prediction divided by to the number of samples. So you only have one value. And you can see the accuracy is very high, 1. All right, accuracy is 1. But if you are careful, you will notice that recall for class 1 is only 82%. That means you have 18% of patients, 1A, 18% of patients are being missed. All right. So this is how we have to understand. So there are other parameters that we can use, which are called micro average and weighted average. Micro average is rather simple. It is just an average of the performance. So micro average calculate the, for example, if for the precision, micro average calculate the summation of the precisions of the classes divided by to the number of class. In our case, this is a binary classification, so there are only 2 class. So you will divide 1.98 by 2 and you get 0.99. Another interesting fact is the weighted average. This weighted average does not just take the mean value. Take the consider the number of samples in this calculation. So here WC is the number of samples for the positive cases and sample for the negative cases. In our case, negative cases we had 12,796 and positive cases 290. So this calculate the weighted average. All right. So far now, we have already learned 10 different ways of measuring the performance of a classifier. This is very important. All right. But don't just memorize how to calculate the numbers, how to get the measurements. Rather than that, try to interpret how does it work. Let's look at this example. In this example, our model is predicting whether mushroom is a poisonous or not. So our model prediction objective is to predict whether a mushroom is poisonous or not, whether we can eat or not. So what is a positive case? Of course, positive case is a poisonous. Mushroom is a poisonous. One will be the poisonous. Negative case is a non-poisonous. All right. So if you look at on the number of sample, we have 162 for negative, 168 for positive. So it is fair, quite a balanced data set. So if you look at this answer, is this classification report, you need to be able to evaluate how does it work. So let's start with the our 0.96 for positive cases. What does a 0.96 precision for the class 1 means? It means that 96% of mushrooms that are predicted as poisonous mushrooms are actually poisonous. So you have tell us that, okay, this amount of mushrooms are poisonous, but only 96% are true. 4% are wrong one. Okay. So now let's look at on the recall. What does 0.85 recall for the class 1 mean? 0.85 means that among the poisonous state mushroom that you provided, which is like 168 mushroom, all right? So out of this 168 mushroom, I was able to predict only for 143. So the remaining 50% I miss it. I could not even, the model could not even do that. So the person who eat this mushroom, relying on your model, will get in trouble. All right. So this is how you have to interpret precision and recall value rather than just looking at the number. Of course, number 1 is the highest and 0 is the lowest. But 1 does not always mean that your model is providing us the best performance. Okay? Especially this is, you have to be careful on imbalanced data set. In this case, this is a classification report that you see. In this case, we can see that the model is actually biased towards the majority, 0 negative cases. All right. And leading to the poor performance on the minority cases for the 290. So out of 290, you are missing out about 20%, which is quite high. All right. So you cannot just look at on the number. 0.82 for this case is not a good case, but 0.82 for another data set might be a reasonable measurement. So when you are using the evaluation metrics, quantitative numbers to measure the performance, always be careful the content behind the numbers. All right. Thank you very much. That's all for this video. In the next video, I'm going to talk about another important evaluation matrix, which is the area under the curve. Thank you.